Hi, welcome back. This is Professor Ridge and today's lesson on section 9.5, common and natural logarithms. Base 10 logarithms are called common logarithms. So common log is base 10. For notation, basically a common log, we just don't write any base. So if you don't see a base written, it's not that we forgot it. Hopefully it's not that we forgot it. It just means it's base 10. So on your calculator, you should see the button that's just log, like that. That's the common log, base 10. She's base 10. Okay? So if I want to know what's, so get your calculator and practice and just say what's the logarithm base 10 of 1,000. Now you got to test your calculator. Some calculators you hit the log button first. Some calculators you hit the number first, and that should be 3, which obviously 10 to the third is 3. Okay, so get your calculator out, make sure you know how to use it. So you experiment, hit the log button first, then the 1,000, hit enter, see if you get 3. If that doesn't work, do it the other way around. Hit 1,000 first, then hit the log button and see if it says 3. Okay, so just experiment with your calculator. And then you can try things like what's the log of and then I'm going to have you round before decimal places. Okay, so say log of 843. Now, no, before you punch 843 in your calculator, you should, in your mind, think, okay, 10 squared is 100, 10 cubed is 1,000. So 843 is between 100 and 1,000, so this should be 2 point something. Okay, so you should kind of have that idea. So 843, hit logarithm. Oh, this one's the other way around. Log 843 equals 2.9. I want you to go to 4 places. That's common. 2.9258. So it rounds to 2.9258. Okay, let's try another one. Log of, say, 0.85. So log 0.85 is negative 0.07058, so 0.6. And these should be squiggly, approximately, right? Because we're rounding. Okay, so make sure you know that. Then the next thing is what's called the natural log. And hang on. Okay, so I got to tell you about the number e first. So e is the exponential number, and basically it comes from looking at this progression. Actually, from studying interest, this is one of the places it was discovered. If I asked you to take this progression, a to the n equals 1 plus 1 over n to the n, and I made you make this table, so if I started with 1, for instance, you get 1 plus 1 over 1 to the 1, which is 2. 2, 1 plus 1 over 2 to 2, and you'd get 2.25. 3, 1 plus 1/3 to the third would be 2.37. 0.37. 4, 1 plus 1/4. Okay, so 100. 1 plus 1 over 100 to 100. That's going to be, and again, I'm rounding, so these are about. So 1.01, which is 1 plus 100th, to the 100. It's 2.7. And what happens, you see we went from 2, 2.25, 2.37, 2.44, and then I jumped to 10, and it just grew a little bit more. I jumped to 100, and this is starting to level out. It's still growing. It's getting bigger, but not by much. Now if I did 1,000, 1 plus 1 over 1,000 to 1,000, and this comes from the compound interest formula, by the way. 1.001 to 1,000. That's 2.7169. And then if I keep getting bigger, let's do 1,000,000. Just to show you, 1 plus 1/1,000,000th. Is that 1,000,000th? Nope. One more. To the million. That's going to be equal to 2.71828, which is close. That's a really close approximation to E. So if we go to infinity, if we can calculate it, we can't, but if we could, that's going to be equal to n, which is close to this number, which is about that. So it's about 2.71828, if I even did a bigger number. So you have this button on your calculator, E. It's above the LN button usually, which we're going to talk about in a minute. You usually see it up there. So it's 2. Here, let me get it on my calculator so I can get a few spots for you. So E is 2.7182818 284 ... keeps going forever and ever and ever. It's an irrational number. So, basically if you just know 2.718, that's good enough for our purposes. Now, my point of that, log, and this is a number that occurs naturally actually, so that's why it's called the natural number. It occurs from exponential growth, so it's called the exponential number. And a lot of stuff in nature that we study has this exponential growth, so this is called the natural logarithm. And we use ln for the natural log. I usually write a script L. Okay, so that's the natural log. Okay, so the natural log, it's base E. E is 2.71828, or about 2.718. So if I ask you to evaluate, so again, look for the button on your calculator. ln of 3. Now remember, 2.718 is E, that's the base of the natural log, so this should be 1 point something. So hit ln 3 equals 1.09, and again go to 4 places. How about log ln of 27? So 27, 3.958, 2958. Right? So try those in your calculator. Make sure you can use it. When you understand it, you'll have a couple on the final. So make sure you bring a calculator that can do logarithms. Otherwise, you'll miss those. Now, most calculators just have, there's some newer ones that have, would let you put in whatever base. Most calculators only have log, the common log, and ln, the natural log, which is base e. So base 10, base e. So base 10, base e. So how can you figure out, well, log of base 7 of 28 equals what? Well, you can kind of guess. 7 to the first is 7. 7 squared is 28. I mean, it's 49. 7 squared. 7 first is 7. 7 squared is 49. So I can try like 7 to the 1.5. Punch that in my calculator. And that's 18.52. So then I can do 7 to the 1 point, we want it to be bigger, so how about 1.6? So 7 to the 1.6. That's 22, we're getting there. Now obviously we don't want to do that, so there's this thing that's called the change of base formula. So let's go to the next page. So the change of base formula. So if your calculator doesn't have the button where you're allowed to put in whatever base you want, and I want to know what log of 28 base 7 is, the change of base formula is really nice. It just says that log base b of m equals log of any base you want to choose of the original number divided by log any base you want to choose divided by the original base. Okay, so this is the, so you get to choose any base. This is the old base. That's the original number. Okay, so if I want to do log base 7 of 28, and my calculator doesn't have any way for me to do that, and instead of guessing and checking, that will take forever, I can go log, and my calculator only has base 10, so I'm going to choose base 10, which I don't have to write the 10 obviously, of the original number divided by log base 10 of the old base, which is 7. Or my calculator has the natural log button, so I can do 28 divided by log of 7. So do this with both of these with your calculator, and you'll see you get the same number. So log 28 divided by log 7, hit equals, and you get 1.7124. If I did it with the ln 28 divided by ln 7, what do you think I'm going to get? And I hope you're saying 1.7124, because I just told you it doesn't matter which one you use, you can pick any base you want. So what base should you pick? You should pick what your calculator has, either base 10, which is just log, or base e, which is the natural log, ln. Okay, so either way you get the same answer. And then just note that if you did 7 to the 1.7124, what should you get? And I hope you say about 28, because remember we rounded. So 7 to the 1.7124 equals 27.9992. So why isn't it exactly 28? And the answer is because we've rounded. It's 1.7124, and there's more digits that I dropped off. So obviously, it's not going to get me exactly 28. All right? So that's the change of base formula. Memorize that one. And it's a big idea. Okay, so since we introduced the number e to you and the natural log, they want you just to get used to graphing. These are things that we graph a lot, actually. So y, this number 47, y f of x equals e to the x. And so what you do, again, this is an exponential function, so if you remember, you just have to do 0, 1, negative 1, and it should look something like that. Okay, so let me make that graph. Okay, so remember, anything to the 0 is 1. E to the 1 is just e, which is about 2.718. And e to the negative 1 is 1 over e, which is about 0.36 or 0.37. Okay, so negative 1 is 0.37, 0, 1, 2.7, and you get that. So that's y equals e to the x. Now logarithm, remember, a logarithm is the inverse function. So this is not an exercise, just example. I'm going to graph on the same one. Y equals x. So remember, we just switched the x and y. So if I wanted to do f of x is equal to the natural log of x, I'm going to switch the x and y from the graphs I did. Instead of doing 0, 1, I'm going to do 1, 0. Instead of 1, 2.78, 1e, I'm going to do e1. And instead of negative 1, 1 over e, I'm going to do 1 over e negative 1. So let's see, remember this is about 2.718. 2.718, 1, 1, 0. So we're going to get this one. So that's the logarithm function. Okay? All right. And then all the rules about, shifting it, it's all the same. So if I wanted to do number 57, it says f of x equals e to the x minus 3. This is up here in the parentheses, so that's going to shift it 3 units right. So it's like I'm going to make my pretend origin at 3, 0. So when I graph this one, it's going to be the exact same shape, but instead of starting at 0, I'm going to start at 3. I'm going to do this. I'm going to think that this is my pretend origin. So I'm going to do 0, 1, 1, 2, 3, 0, 1, counting from my pretend origin. And then 1, 2 point, counting from here, 1, counting from pretend origin. This is my pretend origin. So I'm just graphing this graph up here. 0, 1, 1, 2.78, so this would be 1, 1, 2.78, and negative 1.36, so right about there. And that's all there is to it. And then same thing for natural log. If I did 65, g of x is equal to ln of x minus 2. Now this is outside the function, so this is moving it down to. Should have parentheses like that so there's no confusion. So I'm going to take this graph up here and just shift it down to, so I'm going to make my pretend origin right here. And I'm going to count 1, 0 from the pretend origin, 1, 0. Then I'm going to do E, which is 2.71. So see, that's really 2.7, negative 1, but I'm counting again from this point down 2 from the origin. And then let's see, that was 0.36 down 1, and then it's a log function. It looks like that. All right, so that completes the exercises for 9.5. Go to MyMathLab and complete your exercises there. Looks like we just have a few more sections left, and then that'll be it for the year. All right, see you next time.